Hi, my name is Harry and I'm with the WP Failsafe company. WP Failsafe is introducing a new and innovative product for the construction industry. The product is a plastic form that is used to make pier type concrete footings that are used in the construction of decks and pole barns, cottages, many types of structures, and it has also been adapted to be used for pier and grade beam type construction projects, and has been adapted to be used to support overland oil and gas pipelines. For a brief review of what the product is, I'm standing in front of it right here. Again, it's a plastic form, and it is bell-shaped, so it will be creating a bell-shaped concrete pier footing. It comes in a kit like this in pieces and snaps together in a matter of minutes. So in order to effect the use of it, what you would do is you either excavate or auger a hole in the ground, snap the footer together, snap the rebar in place, drop the plastic form with the rebar in the hole, backfill it up to grade. You would take a post connector and put it in the top and let the cement cure like that. And then you're ready to build your structure by connecting your supporting posts into this and to build the structure. And you'll be building your structure on a foundation that meets the 2006, 2009, and 2012 IRC and IBC codes. Additionally, it exceeds those codes and will provide for you a foundation that will provide security for many years. Now, in order to understand the benefits and the advancement brought to the marketplace by this form footer, it's probably a good idea to take a look at the methods that were in vogue prior to the introduction of the WP Failsafe form footer. Now, this video is going to be in two parts. The first part will include this brief introduction, and we will review a method that is commonly referred to as the wood post and concrete cookie method. In part two, we will review the cardboard tube type of pier footing method, and then we'll go back and have a final review and take a look at the other features that are incorporated into the new WP Failsafe form footer. So just briefly to go into a little more depth onto the Failsafe footer. The footer comes in two sizes. It comes in a size which has an 18-inch base and a 25-inch base. The difference in the bases are designed to accommodate different load factors. The footer also comes in different heights, adjust to different heights, and that it can be extended from the low point of 18 inches all the way up to 72 inches by just snapping in 18-inch tower sections. It could also go up to 90 inches under certain circumstances. All right. The most important feature and advancement that the Failsafe footer brings to the marketplace is that it has horizontal and vertical integrated rebar incorporated into the plastic form. So that means that the form is snapped together, and then additionally it comes in the kit. This horizontal rebar in the bottom is snapped in, and the vertical, so the cement is, when you pour it in, is reinforced in bringing an enormous strength and stability to the foundation. So in order to really make it clear why that's so important, let's go over and start with taking a look at the wood post and concrete cookie method of pier type foundation construction. Essentially, this is a wood post, this is a concrete cookie. Well, let's start with the cookie. In this type of construction of a pier type footing, you would auger a hole into the ground, and then you would buy from off-site at a store that makes these precast concrete cookies, a cement cookie. In this case, we purchased a 15-inch diameter cookie that's 6 inches thick. You bring it to the site, and then you need someone much stronger than me, more like an Arnold Schwarzenegger guy, who can pick this cookie up, hold it over the top of the hole, and drop it in. Now, let's say, for example, in Michigan, he's going to drop it down 42 inches. Now, there's no way that when you drop that cookie down 42 inches into a hole that it's going to land level. It's going to land a little bit sideways and dig in. Now, it's imperative for this concrete pad to be level. And because when you're going to build your structure on top of it, all of the loads that are in forces that are developed above ground are going to be transferred all to this concrete cookie right here. So it needs to be level. So what the construction guys will do is take a hose and put water in the hole here and get it nice and wet, and then they'll start tamping it like this, trying to get this level. Now, common sense will just tell you that it may approximate level, but it's never going to be right. So the first deficiency here is that the concrete cookie is not level. The second deficiency is that the cookies that you buy at the concrete construction store do not have rebar incorporated into them. So when you have the stresses that are coming down from the structure down onto this concrete, it's subject to cracking unless it has the proper amount of reinforcing rebar in it. Now, one variation on that is that sometimes they don't use a precast cookie, they'll actually do a live pour. And in that case, they do have a chance to get some rebar into this concrete cookie. Now, what they will do in that case, though, is they will have to buy the rebar at the store, bring it to the site, cut the rebar, which rebar isn't easy to cut, and then you're going to have to bend the rebar, wire it together in a cage, and then you have to have Arnold back, and he's going to hold one of the other workers up by his ankles upside down, and he's going to have to place that rebar cage at the bottom of the hole up on pegs so that when you pour the cement, the concrete or the steel rebar is completely encased in concrete. So right away you see there's a very labor-intensive, costly process in order to get the rebar in the concrete cookie. Now, just to stop at that point, here's the base of the WP Failsafe form footer that goes at the bottom of our bell-shaped plastic form. As you can see, it comes in the kit with this rebar pre-cut. You just snap it in place in literally a minute and you're ready to go. The other thing is that if you're doing this method, every time you do it, it's going to be different. There will be no consistency to the rebar that's in the bottom of that cage, and who's to say that it's properly placed or that it's not sticking through and exposed to the dirt where moisture can get up into it. So, you know, you have the issue of consistency in meeting the standards that are required for a good reinforced concrete cookie. Let's go forward from that. Now let's take a look at the post. The post is a wood post, and let's say if it's done correctly, it's going to be sitting right in the center of the concrete cookie. However, it's not connected to the cookie. Now, the number one thing is that the IRC and IBC codes require that the load path from upstairs here where the structure is be transferred down through positively to the foundation, which would, in this case, is this concrete cookie. Well, you're not connected to it. So there are going to be forces that are going to come to bear on the structure that could make this move. Now, let's say, for example, you've got a pole barn or a deck. Essentially, they're big kites in the wind. The deck can get uplifted, from the wind, lift this up a little bit. The pole barn or whatever, if you have a sunroom upstairs, can make this rock like this. It's not connected down here. Any motion to the structure is going to cause it to deteriorate and cause it to be damaged and weaken and eventually fail. So, number one, the post is not connected to the foundation. Secondly, or another point, is that the post may be not centered on this cookie. They go to line the beams up, and since they're already being a little careless by using this, dropping this in the hole, and it's not level, well, they're trying to line their beams up, so this winds up side loaded. So now, for sure, when the pressure comes down here, this is going to tip. So now you got another problem. So the last issue is, what is this wood post made of? This wood post is a Wallmanized wood, which essentially is wood that's been pressure treated with copper arsenate and other oils and chemicals that are impregnated into it to resist it from absorbing moisture and to stop bugs from eating it. Well, the U.S. government changed the standards for how much copper arsenate and chemicals can be put into the wood. So the wood that your fathers bought many years ago was much more stable in being buried underground than would be the new treated wood, because they don't allow so many chemicals. To make matters worse, let's say you have to cut this beam to length, and you cut it here, and here's a cross section of it, and the wood is pressure treated so that there's a lot of chemicals on the let's say for up to 1 inch in, but the center of it has little or no chemical treatment. So now that's an exposed edge end. It's set down in the ground, and it's now absorbing the water up through the center and rotting. And to make matters worse, you have the concrete cookie 42 inches down, this post down in the ground, it's backfilled to here with pea gravel, and so whatever's happening down there you can't even see. So you would have rot or other things happening that all of a sudden you have a catastrophic deck failure or pole barn failure, rather than being able to at least see what's happening. So why don't we just end part one right here, and I'll say hello to you in a few minutes for part two.